Hi, I'm an old guy and I do maths. And what we're looking for today is the area of this shape here. Now, the first thing to do with a problem like this is to look at how it's made up. And this is constructed from a square measuring 5 by 5. So I'll just make a note of that here, 5 by 5, and the area of that is pretty straightforward. It is 5 times 5, 25. So we know the area of this space here. Now, this thing here has got a width of 5 like this and a height of 5. So it started life as a square just like this, and it had a chunk bitten out of it, so to speak. Now, this is 1/4 of a circle. I'm going to draw that over here badly. But what has been bitten out of this, if I can use that term, is this part of the circle. So our job is to find out what that area is and subtract it from what would have been the square here. We're not going to find the area of this shape straight away. It's a two-step process. We find the area of this shape, the quarter circle, and we subtract it from the area of this shape, which is what this would have been without that being taken out of it. So let's go to work. What do we know? Well, the area of a circle is pi r squared. Area equals pi r squared. And what we have got here is we have 1/4 of that. So the area that we're looking for is going to be pi r squared divided by 4 to give us 1/4 of that. So what is the radius of this? That's the key thing. We know what pi is, we know what 4 is. What is the radius of this thing? Well, this point here corresponds to this point here in my badly drawn diagram, and we know that that's 5, so the radius is 5. So it is pi times 5 squared divided by 4. That is 25 times pi divided by 4. So out with the calculator. And what we get is we get that number there. Now I'm going to call that 19.63 because I'm not terribly interested in 10-digit accuracy here. I'm interested in demonstrating the method. But if you were working on this and you were asked to give an answer to 2 decimal places at the end of your calculation, you would retain all of these decimal places, all of these decimals, until you got to your final answer, and then you would indulge in some rounding. Anyway, just to speed things along, we're going to say that this area in here is 19.63 square units. We don't have measurements as such for this. They may be in the header, but I've forgotten what they were. So we'll call it units. So this area here is 19.63 units. So we have 25 units squared for this part of the diagram, and we're going to add to that 25 for this minus the 19.63 units squared. So that gives us 25 plus I'll just subtract the 19. That gives us 5.37 units squared. And so the total area of this shape is 30.37 units squared. With the proviso, as I said, that normally what you would do is you would keep all the decimal points, all the decimal places here, and you'd wind up with a number here with 8 or 10 decimal places, and then you would do your rounding. But as I said, what we were interested in was the method here and looking at how you deal with this shape. And just to reiterate, you break the shape up into things that you can easily recognize. When you get to this, you have to think about how such a shape was made. And very kindly, the problem provided us with this dotted red line to hint at the fact that this started as a square and had a piece removed from it. Anyway, thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I will see you next time. Bye.